I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you want.
So I received a question on YouTube from somebody, Abdullah, from somebody wanted us to do this question. So let's do this question together. But you need to make sure that you explain it so that whoever is doing it understands it. Are we together, right? Like we need to explain it like we've never, like we're explaining this to someone who's never done electrical engineering before. Okay, so let's start. Now, this question is actually very simple, right? Because this question, your currents have already been given for you. You already know that V1 is producing I1, V2 is producing I2, and then V1 plus V2 is, they join together, then they flow through the load resistor. So this question is already easy. A lot has been done for us. They have already given us the name of this circuit, right? Which is A, B, C, D, E, F. This circuit has already been simplified for us. So the very first thing that you need to do is we need to form loops, right? Now, this is going to be loop. Can you give me a loop?
A, B, E, F, A.
F, A, that is correct. Now, the loop that we're forming in this case, since we're looking for current flowing through the load resistor, let's just form loops that flow through the load resistor, right? So that there's no need for us to form a loop that goes A, B, C, D, E, F, A, right? There's no need for that, since we're looking for this one, right? So, after we've created our loops, we're going to follow Kirchoff's laws. So just a quick reminder for Kirchoff's laws. Kirchoff's first law states that current in should be equal to current out. That's Kirchoff's first law. Current in should always be equal to current out. And Kirchoff's second law states that the voltage supplied, the total voltage supplied should be equals to the voltage used. Are we together? That means that if your battery is supplying 12 volts, right? That means that all the resistors that you have, they are supposed to use up all these 12 volts. Are we together? Or in other words, the voltage drop should be equal to 12 volts. Are we together? And we're also going to do a recap of Ohm's law, just in case, right? Now, Ohm's law says V is equals to
I times R.
Thank you. I'm too young for a heart attack. I times R. That is correct. So these are the three formulas or the three laws that we're going to use to calculate this part. Now let's just go over the rules of our loop, right? The first rule says that your loop needs to start where it stops. Are we together? So if our loop is starting at A, it goes A, B, E, F, and then it needs to go back. Like in other words, your loop needs to be a complete loop. And then the second part is more like a caution, right? That says if the current that you are working with is going against the direction of your loop, then the current is
negative.
That is correct. So if your current is going this way and our loop is going this way, then that means that current has to be negative. Are we together? Now let's start. Now we start off with a formula for Kirchoff's second law, which says that the total voltage supplied is equals to the total voltage used. Now, the voltage that is supplied is here by the battery, which is VT, and the voltage that is used up is going to be voltage used up by the load resistor, voltage used up by R1, right? So that is V1 plus
V2.
That is correct. Let me change the marker. V1 plus V2, right? Now, let's move on and let's now expand. Now, our V total is still our V total, right? But we said voltage is equals to current multiplied by resistance. So our loop is going like this, and then we're going down here. Now, since we're down here, our current is flowing together with the direction of our loop, right? So our current in this case is, in brackets, I1 plus
I2.
multiplied by the resistance, which is RL, right? Plus, and then when our current is going back this side, what's the name of the current that we have here? It's
I1.
I1, that is correct. Because I1 was here, and then it separates here. It's now I1 plus I2. It separates, I1 goes in this direction, and I2 goes in this direction. So here it's now I1 multiplied by R1, right? And then after this, we put in the numbers. Our total voltage is given to us as 4, right? And it's going to be I1 plus I2 multiplied by RL, which is given as
15.
That is correct, times 15 plus I1, and our R1 was given as 8. That is correct. Now let's do the mathematics now. So it's going to be 15 times I1, you get
15 I1.
That is correct. 15 times I2, you get
15 I2.
That is correct. And 8 times I1, you get
8 I1.
That is correct. Now apples to apples, oranges to oranges. Let's start with all the I1s. So it's going to be 15 I1 plus 8 I1, you get 20.
3.
That is correct, thank you. 23 I1. And this is the only I2 left, which is 15 I2. Now this loop is complete because you can't solve it any further from this, right? So the loop is done. And then let's create another loop, right? So this is going to be loop
CBEDC.
CBEDC, right? That is correct. In other words, this is the loop that you've created. Starts at C, ends at C. Although this is not really necessary to write it, but I always feel like it's best to know the rules for your loop, right? So your loop starts at C, goes to B, down to E, D, then all the way back to C. Are we together, right? And then we do our formula. Our formula says the total voltage is equals to all the voltage that is being used up. Are we together? So in this case, our voltage that is being used up is here, right? And the voltage that is being used up is this one. So we've got 2 resistors in this loop and a total voltage, right? So let's expand on that one, right? V total is equals to, since we say voltage is equals to current times resistance, we already know that the current flowing through this point is
I1 plus I2.
That is correct. Multiplied by the resistor there, which is
15.
no, RL, right? And then the voltage flowing through this point, the current flowing through this point is
I2.
That is correct. Multiplied by the resistor, which is R2. That is correct. Now let's put in numbers, right? Our total voltage was given off as
10.
Right, is equals to I1 plus I2. And our RL is given off as
15
times 15. That is correct. Plus I2 times our R2 was given off as
12.
That is correct. Now let's do the mathematics. So 10 is now equals to 15 times I1, you get 15 I1. That is awesome. And 15 times I2, you get
15 I2.
That is awesome. 15 I2. And then plus 12 times I2, you get
12 I2.
That is awesome. Now let's do the mathematics, right? Apples to apples, oranges to oranges. We only have got one I1, right? So that is 15 I1. Now we've got 2 I2, so it's going to be 15 plus 12. 15 I2 plus 12 I2, you get
27.
That is correct. 27 I2. This becomes our equation number because there's no way we can solve this further. Now, the question now comes to you. How would you like to solve this one? Simultaneous or elimination? I would rather prefer let's do simultaneous. Let's do substitution. What do you think? Yeah, let's do substitution. Now, if we are going to use substitution, we'll have to form equation number 3, right? So, the choice will be up to us. From which equation would you want us to make our third equation? They look all the same. I rather prefer equation number 2. Yeah, me too. So, and if we are creating from equation number 2, let's start it fresh. Now, 10 is equals to 15 I1 plus 27 I2. Now, I would rather prefer we make I2 subject to the formula, or even I1, one the same thing. What do you prefer? I1.
I1.
Yeah, let's make I1 subject to the formula. Okay, so if I were to make I1 subject to the formula, it becomes 15 I1 is equals to 10. Take 27 to the other side, it turns into 8.
Negative 20.
That is correct. negative 27 I2. And then you divide both sides by 15. Both sides by 15. Therefore, I1 is equals to 10 divided by 15. What do you get? Now, you don't need a calculator for this. 667, right?
I think so.
Minus, and then 27 divided by 15, you get 9 over 5, which is, whoa, I'm awesome, which is 1,8. Oh. Is it 1,8 or 1,9? 1,8. Oh my goodness. I think you're trolling me. Is it 1,8? Oh, I'm awesome. 1,8 IT. This becomes our third equation. Now, you see, whenever I tell you that I'm awesome, you guys need to believe me. Okay, so let's move on, right? Now, after this step, the next step will be to substitute equation number 3 into equation number 1. Why can't we substitute equation number 3 into equation number 2? Because
we use equation number 2.
that is correct. We used equation number 2 to get, I'm going to remove this part, right? We used equation number 2 to get equation number 3. So if we substitute equation number 3 into equation number 2, all the answers that you're going to get are going to be 0, 0, 0 or 1, 1, 1, 1, right? Okay, so let's take our loop number 1. It will be 4 is equals to 23.
I1.
And then for I1, what do we put? 667, right?
7 minus 1,8 I2.
I2, that is correct. And then that is the plus.
I2.
That is correct. 15 I2. That is perfect. Now let's move on with the mathematics. So 4 is equals to 23 multiplied by 0,667. What do you get? This one, I can't do that one in my head. I can try, but I don't think I can.
4 times.
No, you want to do it with your head. Say 23 times 2, which is going to be 46. 46 divided by 3, which is going to be 46 divided by, don't tell me the answer. I am getting 46 divided by 3, I am getting, I know the answer. The answer is 15, right? Comma 3333. Oh man, I'm awesome. 15,333, right? Minus, and then 1,8 multiplied by 23. What do you get? I'm too lazy to do this one with my head. Plus I've been winning too much. I don't want to lose. What do you get? You want to do it with your head? Oh, wait, just give me 2 seconds. How are you doing it with your head? You know what I think you need to do? I think say, wait, don't tell me the answer. Say 23 times 2, you get 46, right? Now say, this is 2 minus that. That's a 0,2, right? Say 2 times 23, you get 46 as well. But then it's a 0, right? So that's 0, that's 4,6. So say 46 minus 4,6, what do you get? 46 minus 4,6, what do you get?
42, you said
no, 41,4.
40, yeah, 41,4.
Was that the answer for
You said 0, what?
I said 1,46.
No.
Sorry, I said 4.
No, I said it's 0, what? 4,
You said 4. You said 42,6.
You said 46 minus
4,6.
6, so it's 41,4.
Yeah, that was my answer. Is that the answer for these two?
Yes. Yeah, go. But for 15, it's 15,341.
If you say 23 times 1,8.
For 23 times 0,667
is
15,341.
Or it's because of rounding off.
Yeah.
It's because of rounding off. This is the correct answer. That one is because of rounding off. If you use 0,667, then this answer is rounded off. Okay, so for this one, we got 41,4 I2 plus 15 I2. Now, apples to apples, oranges to oranges, right? So it's going to be 4 minus, take this one to the other side, it becomes a minus, right? 15,333 is equals to negative 41,4 I2 plus 15 I2. Let's start from this side. This one minus that, what do you get? Negative 11, comma.
11,33.
That is awesome. And then 41,4 minus 15, we get 26,4, right?
No, negative.
I'm on fire! I'm on fire! Negative 26,4 I2. Minas are on fire today. Okay, then divide both sides by negative 26,4, both sides by negative 26,4. Ta, ta. Therefore, I2 is equals to 0, I've been correct for way too long. Now I don't want to mess it up. But I'm getting 0,4. Am I correct? 0,40 something or 0,39. Probably 0,39.
It's 0,429.
Oh, I should have staggered 0,4. 0,429 amps. This is our value for I2. Are we together? Then now let's calculate our value for I1. Right? So we know from our third equation there, which says I1 is equal to 0,667 minus 1,8 I2, right? So it's now 0,667 minus 1,8, and our value for I2 is 0,429, close bracket. If you punch everything into the calculator, what do you get? I feel like this is the correctest answer, because this answer is the correctest answer that you can get. The calculator would have given you a rounded off answer.
It's negative 0,105.
Negative
0,105.
105 amps. Okay, so let's talk about something, right? Let's talk about the reason why our answer is negative. How come I1 is negative, right? Who's got an answer? Now,
The answer is negative.
yes, what is our answer for I1 negative 0,105?
The supply voltage
Are not equal. That is correct. One is bigger than the other. So our V2 is very big to the point where it is now charging V1, right? So that means the direction of our I1 here is actually wrong. It's supposed to go in this direction. That means our V1 is being charged by V2. But then the question asked us to calculate the current flowing through the load resistor, right? And the current flowing through the load resistor is equals to I1 plus I2, which is equals to, for our I1, negative 0,105 plus positive 0,429. The answer will be
0,3.
You might be correct.
324.
That is correct. 0,324 amps. Awesome, I'm proud. What do you guys think? Simple, no? Still too simple.
So basically, you must reverse it.
There's the direction, that's correct. Must be reversed.